So I'm going to talk about building applications for the next billion users. Okay, so I'm Siddharth. I'm a JavaScript architect at Practo. This is what I look like on the internet. And you don't really have to take notes for this talk. I'll tweet all of the resources that I talk about right now, so you can just use that. So let me throw some crazy numbers at you. There are 340 million internet users in India. Right? To put that in perspective, the entire population of the United States is 320 million. Right? Imagine that. Yet, this is actually just 25% of our population. Right? That's crazy. And this is increasing really, really fast. Right? So every quarter, we see around 4% more people get on the internet. And so we're actually looking at the true potential of the web booming right now in India. Right? So if you're not building for web, you're actually going to miss out on a lot. The unfortunate part is, Akamai did a study recently where they found that 60% of these internet users have 3G or slower networks. Right? We did some independent studies and found that 40% of our mobile users are on 3G and slower. So it's slightly better, but still pretty bad. Google did a case study on Flipkart's PWA and found that 63% of users are on 2G. That's terrible, right? And there's honestly not much they can do about it. And there have been a lot of studies in the past. This is one study which said that if your website doesn't load inside 4 seconds, 25% of the people have already left, right? So you're bleeding business. And I'm sure you've heard of a lot of studies, Amazon and all of that. I'm going to tell you a story that is slightly lesser known. It's about this tiny company called Google from 2006 when they used to look like this, right? So the folks at Google used to get a lot of feature requests that, why are there only 10 results? I have to go to the second page. Yeah, like interesting times. And so they said, fine, let's give the people what they want. They increased their search results from 10 to 30. And what that meant was the response times increased from 0.4 seconds to 0.9 seconds. Still sub-second, right? Everything's cool. Unfortunately not. They actually saw a 20% decrease in traffic. Imagine that. So if that can happen to Google, imagine what must be already happening to you, right? I hope you're all adequately worried. So that's where I come in, right? I'm going to give you some performance tips which will help you optimize your websites and not lose any of those users, right? First, performance tip number 0 is if you can't measure it, you can't improve it. So let's talk about some measurement techniques. And there are like a bunch of them. I did a very scientific research where I found that regular audits using Lighthouse or using developer tools is the most popular way of doing it, right? You also have synthetic monitoring tools like SpeedCurve, Caliber app, which basically run your website on say a low-powered mobile on a slow network and push the results back to you. There is real user monitoring, or the better name is RUM, like New Relic, which basically you add a tiny snippet on your page. It will search the results, it will actually calibrate your website on the user's machine and send back you the data. The last one is continuous integration, which is basically not on production, unlike some of these approaches. It's actually pre-production. So you automate all of the benchmarking, and if the build does not pass, you actually do not push it to prod, right? So how many people in the room use some kind of CI, like Travis, Circle? Oh, that's a pretty nice number. Awesome. So the first thing is you have to benchmark on slow networks and slow devices. That's where your users are. And DOM, content loaded, time to first byte, these are excellent pointers for developers, but not really metrics that your users care about. So what they care about are these things. There's the first meaningful paint, which is from me entering the URL to the time that I actually have useful content that I can start consuming. That is first meaningful paint. There is time to interactive, when the JavaScript's main thread is free enough to actually handle my user events like scroll. You must have seen in a lot of websites, there's a lot of processing happening, and when you scroll, it actually janks, right? That's because the main thread is not free. The last one is page ready, which is when all of your JavaScript, all of your resources have loaded, and the user can actually start doing actions that he came for, right? Book an appointment, add to cart, that kind of stuff. So we built something. It's called practo.com/medicine-info. And you don't? Cool. So we built this thing where you enter a medicine or enter a brand like Crocin, and then it will tell you the description, the side effects, what are the alternatives, things like that, right? And it's a great website. It's built with React, Redux, all of the jazz, right? Inshallah, the boys have played well. They've created this, right? And cricket jokes, like this country is so good with cricket jokes that you just have to throw something and people will like. Okay, so what I'm going to do, I'm going to go to the performance tab in my Chrome. It's going to be slightly tricky because half of my screen is actually out, so please deal with that. And I'm going to throttle my performance to 4G and CPU to 5x slowdown because I want to measure it on slower devices. And I'm going to hit this reload button. Awesome, okay. So now you'll see that this is your usual good old website. There is the HTML document that gets served. It's only 877 bytes because all it does is that actually tells you that load these styles, load this JavaScript, and move on with your life. Yeah, and this is going to be complicated. Right, so now you see that what it does is it loads this HTML, it loads the styles, it loads some JavaScript, right? And this JavaScript gets evaled. And then after all of this is done, it makes some AJAX request to actually fetch the data. And then when the data is also parsed, then that is when you actually see the content, right? So if you see, this is the content. And it's an excellent website, right? But it actually doesn't paint anything till 2.4 or 2.5 seconds, right? That's pretty bad. Like I just mentioned that time to meaningful paint should be less than 1.6 seconds, right? This is actually pretty bad, right? The boys haven't played that well. So, but that's okay. Like we can do something about it. So you see that the initial request actually comes really fast, right? It's right here. And it's the data that we actually have to wait for. So if you'll have to deal with a lot of this. Okay, let's go to 301. Okay, now when what I want you to notice is this, right? So what I've done is a lot of websites do this where they basically, till they're actually loading this data, they show you something, right? Like skeleton screens. Like this, right? Flipkart, I think, was the first one, and then Medium followed it later, that they show you something, right? So that the users keep waiting. Let me just reload this. And yeah, so you see these gray things, and then the actual content loads, right? And what's interesting about this is that now the paint actually happens the moment I have my HTML and my styles, right? It's somewhere here, below 1 second, which is great. But think about it, is this really meaningful content? It's a paint, right? It's a good paint, but it's not really a meaningful paint because you can't consume data, right? And I want to argue that it's probably worse. So imagine you're a user, you're actually traveling, you're on the train or something, right? And you load a website. And when you see nothing, right, who do you blame first? You blame your internet, right? But when you show this, now the user knows that you've got his request, but you're the one who's actually making it slow, right? It's your fault. So he's going to blame you, which is worse, right? So how can we make this better, right? There is, of course, a lot of things that we have to do. There is data to be fetched. There is some JavaScript to be loaded, right? There's a bunch of things happening. What we want to do is push meaningful paint left of the tree, right for you, right? So on that side, right? And the only way to do this is render meaningful content on the server. And how you can do this is, so I have this thing where I have a Express server, and I start the Express server, right? When the request comes, I fetch data from the API, and then I use that API, pass it as props to my React DOM render to string, and then send back the result, right? So let me just change my port again for you. All right, let's profile this, right? So what you'll see is immediately there was data that came, right? It was much, like it was visibly faster. But let's look at actual metrics, right? So you see that this HTML came, right? It's slightly bigger now. Actually, it's a lot bigger now. You'll see that this is around 49 KB now. Oh, you can't see it. You'll just have to believe me. So it's 49 KB now, right? Which is much bigger than the 1 KB that we had. So because it has all of this data, which is slightly bad, but well, let's look at what this means. And then we have the styles loaded, so there's another round trip to get the style. And then when the paint happens, the first paint is the meaningful paint, which is awesome. and it actually happens in 1.1 seconds, right? So your meaningful paints are really, really fast. Great, right? But I also have this, I feel slightly bad about this because my HTML actually came here. All my content was there. I couldn't show you the content because it wasn't pretty enough. I had to wait for this extra style round trip to actually make it happen. So what can we do? And this is my entire bundle, right? What we should do is split this bundle, make it tinier, right? Use only what we need and actually embed it in the document itself. This is some place where CSS and JS really shines. So what it lets you do is, because now, and let me show you code first, right? So I have this, right? I'm using style components, and I have a search input, and the styles for the search input are right there, and then I use it in my render function. And what this gives me is, because my styles are now co-located with my component, when I render these components, I actually only get the styles that I want, right? And it's great. And of course, you can do all of these things with CSS as well, right? If you can organize them better. But this way, you can make the computers do the hard work. And the best part about this, what I like is, because now they're co-located, I can actually keep all the functionality, the display, the styles together, and do things like this, right? I can import a button from a central UI library across the company and use it, right? So we have multiple products. We want all of them to look and feel the same. This actually lets us do that. All right. So awesome. We've got that. Let's see how that works. OK. I'm going to prepare for the next one. Sorry that you have to see all of this. All right, so I'm on 3. All right, let's render this. Right. Here we go. Here's the request. All right, awesome. So now if you see, I have this HTML, and there is no extra CSS because I've actually embedded the critical CSS into the file, right? And of course, this means that the size will go up. So if you see over here, or if you trust me over here, the size has actually gone to 61 KB, right? Which is 10 KB bigger than the previous one, but there is no extra round trip. And in a country like ours, where latency is what really kills us, right? This is really, really useful, right? And the obvious question to ask over here is this bad for SEO? We spent a lot of time giving that first paint, right? So the answer is kind of, right? So when you benchmark this website, it actually gives you a score of 97 on page speed insight, which is really, really good. But the only complaint that it also has is that the server responded too slow. It took like 0.4 seconds for them to actually get the first response, right? Which will hurt your SEO. So what you can do is start streaming the HTML. So an interesting thing about document is that, unlike JavaScript, which cannot be parsed and compiled until the entire chunk is downloaded, HTML can actually be parsed chunk by chunk, and the browser will actually start executing it, right? So what you can do is stuff like this. The moment you get the request, write the static HTML back, flush it, send it down the wire, then make your API request, get the data, and then send it as well, right? So you can, the static parts of my page, like my navigation, my search bar, the styles required for these don't change according to route. So I can actually just cache them, send the static HTML, and then send it. So your time to first byte is good, your users are happy, your SEO is happy as well. Awesome. OK, but that's just first part of the picture, right? That's just meaningful paint. What about interactivity, right? So let me look at this. So I have my HTML come here, it's paint, awesome. And then I have this functionality of search over here, right? So when I go here, I say search for Paul, right? It hits the API, it actually searches internet. So it hits the API, and it actually gives me the results back. And so as you can guess, to do this autocomplete thing, I need JavaScript, right? I need to make AJAX requests. I need to make this fancy autocomplete thing. And to be able to do that, I need all of my JavaScript to get downloaded and executed. So this is where my JavaScript happens. And this, if you, so this, if you see, is the eval of this JavaScript, which also takes around 700 milliseconds, right? So we're benchmarking on slow devices. Parse time is no joke. It actually takes a lot of time. So, and if you see over here, time till actually I have the first paint to I have search working is 1.9 seconds, which is pretty bad. This would mean that the user actually has the website, and he's typing on it, but nothing has happened, right? This is really frustrating for your users. They're typing stuff, but nothing's going to happen, right? Terrible. So first thing, if you can't measure, you can't optimize. So what you do is you can add custom performance entries by saying performance.mark and add this, right? So for example, in the search container component, I'm actually adding performance.mark search ready on the component did mount. This is when I'm sure that the events are bounded, everything is ready, right? And you can actually see the event log over here, and if I search for search, I would actually get it, right? So let's see what that time is. How much time does it take on a 3G to get search ready? It actually took 3.0 seconds, right? Almost 3 seconds, not good, right? My meaningful paint happened in 1 second, but for the next 2 seconds, he can type all he wants, nothing is going to happen. Terrible. And so there are a bunch of reasons for this. If you look at the JavaScript bundle, right, and if you look at the size for it, for example, this one, scroll, oh wow. Yeah, so if you look at the size for this, the size is actually around 56 KB, right? My bundle actually has React, which is now pretty tiny. With React 16, it's actually just 3 KB, amazing. But React DOM is still pretty big, right, which I need over here. So my bundles are still pretty big, right? So what can I do for that? The performance tip number 2, which is the first thing you can do here, is load the least amount of JavaScript required for a page or route. You have multiple pages in your application. There are multiple steps. Each require different components. So split your bundles and only serve the amount that you need. You can do this by using code splitting in Webpack. You basically define multiple entry points for each of the pages that you have, and then it will create different bundles. You load only the one that is required, right? But in some cases, that is still not enough. Your bundles might still be pretty big, right? Because you have some analytics library in it, you have some notifications, you have the school pop-up that says, please subscribe to my blog, right? And all of those are good, but not really what the user care about, right? That's what you care about. So need to optimize for the user first, and you can split your bundles further and actually serve content that matters to the user first, make it interactive, and then lazy load all of the fancy good-to-have functionality that you have. So we actually do this over here, where you see Mixpanel, analytics, all of these collect thingies happen much, much, much later, right? The last thing that we did on this website is actually move to Preact. So moving to Preact is pretty easy. The docs have a pretty good step-by-step procedure on how to do this. You basically alias. And the key thing that we got over here is we could alias React DOM with Preact Compact, right? Which is a 4 KB alternative and to a 38 KB library, right? And which actually meant a lot for us. And if I go on this port, yeah, let me just reload this thing for you. And the key part over here is that the file size actually reduces a lot. So yeah, my common files actually reduced from, reload. Anyways, no. My common files actually reduced from my vendor bundle, reduced from 56 KB to a 20 KB, right? And it's like that much faster to download. You can't really expect a lot of improvement in parse. The parse times are still that bad, but this part is really, really fast. And what this means is my search ready actually gets optimized by a lot, and it comes down to 2.1 seconds, right? So from a 3 point something to 2.1, and basically it's interactive below 2.5, which is awesome. So those are the 3 things that we did. But that's not all, right? There is still this phase where you're downloading this bundle, and it's still 2.1 seconds, right? If you're on 2G, it's going to be much, much, much worse, right? And so what you can do over here is have a 2-stage architecture. What I mean by that is you start with a server-rendered functional application, which works to a certain extent, and then as your resources, as your bundles arrive, you progressively enhance the features of your website, right? Mario reference, any 90s kids? Really? You guys are not that young. Okay, so for example, I have this, right? And to demonstrate, let me just go offline. Let me disable JavaScript so that I know that this is a proxy for JavaScript was not served. And then when I search for stuff, nothing really happens because I can't make those AJAX requests. But when I hit go, I actually go back to the server, render the page, and serve it back, right? So my app basically is fully functional without any extra JavaScript because everything can be rendered on the server and returned. But when you do have when your JavaScript bundle eventually arrives, you can have better functionality, better UX by having an autocomplete and add to cart and fancier things. Internet. All right. The last point here is anticipation is the key to performance, right? So most of us works on products that have good well-defined user journeys, right? So, and what you can do in these user journeys are prefetch and start caching the next page. For example, let's take the example of an e-commerce website. The moment your user clicks on add to cart, you can actually start fetching the checkout page because you know that's where he's going to go next, right? So start prefetching resources for that and caching. When he's on the checkout page, start fetching resources for your payments page. And this is basically how it works. So I'm using a service worker here, and the awesome thing about service worker that is often missed is that you can actually talk to your service worker on runtime. So over here, I'm actually just sending a message to my service worker. This is a custom method cache, and I'm passing the URLs, that these are the URLs, please cache them. And in my service worker, I can listen to this message and say, okay, I just got an event. If the method is cache, I'm going to open the cache, put all of the URLs that you told me in the cache. Right? This is excellent for us. So what we did with this, all of these, let me change my port once again. So what we did with this was, we have this thing called substitutes, and we actually saw a lot of people use these substitutes. Because as Indians, we always look for alternatives, especially cheaper alternatives. So when you click on this substitute, right, it loads really, really fast. Okay, right now my service worker actually did not initiate. Demo gods. So what I can do is actually cache all of these URLs by using the runtime cache of service worker. And when I click on this calpol, it actually fetches the data from the service worker, which is extremely, extremely fast because everything is just in the browser. So even if you go to 2G, even if you go offline after that, doesn't matter. The data is already there on your browser. All right. So what was the business outcome of doing all of this, right? Like performance is good. All of us are developers. We understand these things. But how do you convince your business people that this is actually worth it, right? So the first one is scare them with numbers from others, that if you're actually losing users. The other thing after this performance boost, what we got was we got 30% increase in user retention. So, and also user engagement. So our users are spending 30% more time, clicking 30% more things on the website, which means they're spending and interacting a lot. So if you want to monetize this, right, it actually makes a lot more sense. It's basically a 30% increase in your top funnel for conversion. Great. That's what your business people care about. The last part that I want to talk about is, cool, you've made your awesome website, it's super fast. How do you stay performant, right? How do you make sure you don't get performance regressions, right? Say your product manager says, can we add this awesome feature, right? It will increase your business a lot. A new intern joins and he adds a tooltip library, which is 10 KB, right? How do you watch out for those things? How do you stop those things, right? If jQuery pees all over the place, how do you stop that from happening, right? So the first thing you can do is put your JavaScript on a diet, right? Think of this as having a budget. So we saw that when we reduced our JavaScript bundle from 50 KB to 20 KB, our performance did improve, right? And I don't want our JavaScript to bloat again. So there's this module called bundle size, which you can install as a dev dependency, and then add it to your test scripts, and give it the size. So for example, here I'm saying my common JS, which is my vendor bundle with a star because hashing, right? Limit the size to 25 KB. My brand page, limit the size to 30 KB, right? And the moment somebody builds a feature which exceeds this, my builds are going to fail, right? So this is GitHub UI. So you see that one of the files actually went to 26.2 KB, and I can only allow 25, it's going to fail, right? So this is a great metric to use when you're kind of judging, should I add this feature, should I add this library? What events are you loading? Go, yeah, right. So this is really, really useful. And the best part is you don't really want to do this manually. So you automate it, push it to the CI, forget about it. When there's a problem, it will remind you. The other feature, which is still a beta thing, is this thing called perf-bench, which, again, you install as a dev dependency. And what this lets you do is you can actually test performance in an automated way. So you have a pre-test tag over here, which is basically I'm building my website and running it on my local host in the CI. So Travis is running a local version of my entire website, right? And then I can run perfbench, and I can drop a .perf.yaml file where I can actually tell that this is the website, this is the URL, so I'm testing my Croson page over here, and these are the thresholds that you should look out for. So by default, it looks out for the thresholds that we already discussed, meaningful paint, 1.6, all of that, but I've actually improved meaningful paint more than that. I don't want a performance regression. So what I do is I define meaningful paint as 1,000 milliseconds, 1 second, and a custom metric that I marked was search ready. I can also add that and say search ready, look out for it. It shouldn't go beyond 2.5 seconds. And it does the same thing. It gives you it runs your build in CI, checks for performance regression, puts it back on the GitHub UI, right? So for example, over here, you see that the test passed, but it also compares it with master and says that, warning, time to interactivity has increased by 229 milliseconds, so something is happening. Better watch out for it. So it gives you a nice, pretty UI. You click on the details page, you get all of the metrics that we discussed, compares with master. You can basically, so the idea over here is that whenever you build a feature, you don't have to manually do it, manually benchmark it, push it to your CI tools. All right, I'm almost out of time. Let's talk about the takeaways. First takeaway, the performance checklist. Render meaningful content on the server. Load the minimum amount of JavaScript that you can for a page or route. Lazy load good to have features. Prefetch, like greedily prefetch and cache the next page in the user journey. Stay performant with CI tooling. Automate all of the hard work. The last one is this thing called 2G Tuesdays, which Facebook made it popular. And it's a really good idea. So the idea is that everyone in the team, and not just QA and developers, even product managers and the sales team, actually, on a Tuesday, they get a pop-up where they say, do you want to use this website on 2G? And they click yes, and the website actually loads as if they were sitting in a developing country on a 2G network. So it's great for building empathy amongst your team to see what is the performance that your users are seeing, because all of us sit on excellent Wi-Fi, like other than conferences, and on great MacBooks Pros, right? Like there's insane amount of RAM on this thing, right? This is not what the users are using. So test on devices, build empathy. Wish you some happy users. I'm Siddharth KP. My DMs are open, say hi. These poor guys. Mad props to these guys who built the entire website and maintain it. Great work with it. Thank you.
Thank you so much, Siddharth. Do we have any questions? I think we should add some performance check on our, we are running late by 15 minutes, probably. Jokes apart. Any questions? I do not, yeah.
Hi, nice talk.
Hi, Manju.
So, yeah, hi. So, what are the challenges you all faced when you all migrated from React to Preact?
So, all right. So this is a very interesting question because it kind of gets missed a lot. So there were basically three things that we faced. The first one was that there's an easy way to alias for Webpack, but if you're doing server-side rendering, then it's a challenge because you'll render on the server with React and then push a Preact bundle on the browser. So how does the reconciliation happen, right? How do the checksums match? And so the first thing is you have to use Preact on the server as well. That's one thing. There's Preact render to string that actually helps you do that. The second one was we use React Helmet, which just did not work. So we had to port to an older version of Preact Helmet. Basically, any libraries that you use, you have to kind of find Preact alternatives to them. The third one was we use style components. Hi, Max. And style components kind of depends on React. Inside the code, they assume that React would be there, right? So what you have to do is also alias React with Preact on the server. So there is a tiny NPM module called module alias. And so before we start the app, we push it out there and say module alias React with Preact, and then all your server rendering style libraries are also happy with it. So those were the three things that we actually faced.
So did you all also face a difficulty with the life cycle? So I think component did mount in React. If you have written some code in that, React does not consider that. This is what currently we are facing.
Sure.
Because the life cycle method of the Preacts are a bit different, right?
Not really. At least the docs promises that all of the lifecycle events are same, at least till React 15, and we actually did not face it. So I'm using component did mount, will mount in a bunch of places,
Okay.
and it seemed to work fine.
Okay, cool. Thanks.
Thank you.
Hi, Siddharth.
Hey.
So, this is commonly two patterns are used for the Webpack maintaining a bundle for page.
Okay.
So one is the multiple entries and another thing is code splitting. So what do you think is more performant, or what fits for certain use cases?
Sure. So I think both of them have their own use cases. And so the use case for entry points is that if you already have well-defined pages or routes like we did, we went with entry points first because it would create different bundles for them. So this is during your build time, right? And then if your entry point still requires more JavaScript, so this is still one bundle, right? If you still require more splitting of this, then you go with dynamic splitting with dynamic imports, where you do the second part of code splitting. So essentially what I'm trying to say is you use both, right? The second one, dynamic imports, is only when you have things that can be lazy loaded, right? But entry points always exist when you have different pages that you can split. So use both whenever needed.
Hi, nice
Hey.
talk.
Thank you.
So my question is about preloading. So what are the various ways of preloading the next set of bundles or a set of bundles? And also, like we beforehand we would not know like what actions user is going to take, and different actions can mean to lead to different pages, right?
Sure.
So how do we decide which to load, and what are the various ways to do
Sure.
that?
So I would split this problem into two, right? The first one is if you have different points in your user journey, then always fetch the next point in the user journey. For example, the cart example, right? If you're on the cart page, you know the next is checkout page, right? And there is, of course, a time where he might bounce on that page, he might never go to the checkout page, and you just use his data to actually for nothing. But that's the, what do I say? That's the compromise that you have to take. So you consume a little bit more data to give better performance in the happy case, right? In the successful case. The other thing is, like we had, that after the page loads, that is when I actually know what are the alternatives to this medicine, right? So I don't really know it beforehand, right? In that case, if he scrolls to that part of my website, where basically I list down the alternatives, then you can start caching those pages, right? So it's actually all about anticipation, and you can be shallow and say that I'll greedily fetch all of this, or you can be slightly smarter and say, if you think that the user is going to interact with it, say he did an action or he scrolled to that depth in the page, then I start caching it. So the good part is, even if your response times are like 1 second, right, you have enough time till the user actually does an action and navigates to the page for the service worker to do its magic.
Sure. And what are the various ways for preloading? So
So from a resources point of view, where scripts and stuff, you can use the preload tag, prefetch tag, basically your meta tags. And for dynamic data, like loading entire pages, I don't think there's any other way of doing it other than service worker or a web worker which puts in the main cache.
sure. Thank you.
Hi.
Hey.
Actually, I have some basic question.
Sure.
Actually, you told we can remove CSS and we can add the JS itself, some stuffs we can add, right? But how is it possible? Is it really achievable, all the UIs, everything? Because also the CSS we cannot be able to reuse somewhere also, right? If we add some component in that. So
Sure. So I think this is a question that you'll get a better answer in the workshop after lunch, where Max talks about it. But then I'll give you a short answer over here, is that, so the best way of organizing this is basically you create tiny atom elements. For example, create buttons, create input, right? And then compose them all together to create more complex forms like a pop-up, like, or a modal. And so when you include this in your bundle, it actually only gets included once, which means across your app, wherever you are reusing it, you don't have to repeat it, so there is reusability. It's not as straightforward to see if you're using CSS outside your JS, right, as a standalone file. It's not that easy to see, and it probably is easier to make those mistakes, but if you have your architecture nicely set out as an object-oriented or a Lego-driven CSS, then you'll actually reuse a lot of it, and the performance would be as good.
one more question. We have a lot of third parties, right? So how we will handle those third parties and
how do you use?
We are doing like after window loads, we are loading those scripts. So you are doing the same way, or how it is?
Can you repeat your question? I didn't understand.
So you are loading the analytics or mix
Sure,
or something
sure.
like that, right? So how you are handling that?
Oh, okay. So the key thing here is that the first thing is split into two, right? So the first request that you make in your DOM is to the library, to your code that will make it interactive, and everything else you have to lazy load, right? So there are basically two ways of lazy loading it. The first one is again with tags. So you can use the async tag, you can use the defer tag, right? Adios Mani has a great article on Medium about it, which would basically push these to much later, right, when your thread is free, and then it will start downloading these. The other thing is to actually manually take control and say, from your JavaScript, fetch a file and then inject it into the body, right? So that's the more manual approach. You have more control over it, but it also means more work and less optimizations.
Cool. Thank you so much.
Thank you.